Welcome to another YouTube video. Today I'll be covering extending your network, and we'll be learning about how learn about some of the technologies used to extend networks out onto the internet and the motivations for this. Moving on to task 1. Introduction to port forwarding. Port forwarding is an essential component in connecting applications and services to the internet. Without port forwarding, applications and services such as web servers are only available to devices within the same direct network. Take the network below as an example. Within this network, the server with an IP address of 192.168.1.10 runs a web server on port 80. Only the two other computers on this network will be able to access it. This is known as intranet. If the administrator wanted the website to be accessible to the public using the internet, they would have to implement port forwarding like the diagram below. And here is what it's talking about. Which is design network number 2 will now be able to access the web server running on network 1 using the public IP address of network 1, 82.62.51.70. It is easy to confuse port forwarding with behaviors of firewall, a technology we'll come on to discuss in the later task. However, at this stage, just understand the port forwarding opens specific ports. Recall how packets work. In comparison, firewall determines if traffic can travel across these ports, even if these ports are opened by port forwarding. Port forwarding is configured at the router of a network. Moving on to answer the question below. What is the name of the device that is used to configure port forwarding? And that is a router. Task 2. Firewalls 101. A firewall is a device within a network responsible for determining what traffic is allowed to enter and exit. Think of a firewall as border security for a network, and an administrator can configure a firewall to permit or deny traffic from entering or exiting a network based on numerous factors, such as where the traffic is coming from, the firewall been told to accept deny traffic from a specific network. Where is the traffic going to? Has the firewall been told to accept deny traffic destined for a specific network? What port is the traffic for? Has the firewall been told to accept deny destined for port 80 only? What protocol is the traffic using? Has the firewall been told to accept deny traffic that is UDP, TCP, or both? Firewalls perform packet inspection to determine the answer to these questions. Firewalls come in all shapes and sizes, from dedicated pieces of hardware, often found in large networks like businesses that can handle magnitude of data, to residential routers like at your home, or a software such as Snort. Firewalls can be categorized in 2 to 5 categories. We'll cover the 2 primary categories of firewalls in the tables below. So we have stateful. This type of firewall uses the entire information from connection. Rather than inspecting an individual packet, the firewall determines the behavior of a device based upon the entire connection. This firewall type consumes many resources in comparison to stateful firewalls, as the decision making is dynamic. For example, a firewall could allow the first part of TCP handshake that would later fail. If a connection from a host is bad, it will block the entire device. Moving on to the second one, stateless. This firewall type uses static set of rules to determine whether or not individual packets are acceptable or not. For example, a device sending a bad packet will not necessarily mean that the entire device is then blocked. While these firewalls use much fewer resources than alternatives, they are much dumber. For example, these firewalls are only effective as the rules that are defined within them. If a rule is not exactly matched, it is effectively useless. However, these firewalls are great when receiving a large amount of traffic from a set of hosts, such as distributed denial of service attack. Moving on to answer the question below. What layers of OSI models do firewalls operate at? And that's layer 3 and layer 4. Moving on. What category of firewall inspects the entire connection? And that is stateful. Next question. What category of firewall inspects individual packets? And that is stateless. And that concludes this part. On to task 3. Practical firewall. Deploy the static site attached to this task. You must correctly configure the firewall to prevent the device from overloading to receive the flag. So I'm gonna just go ahead and view site. The website 203.0.110.1 is under attack. Quickly add some firewall rules to stop the server from crashing. The packet in red are from the attacker's machine. So I'm gonna just show you what I did to save the machine, and if you know of a better way, just let me know. But we're gonna start already. I'm gonna add the destination IP. So that's what I did. So it might have been at port 80, but overall I just added a bunch of them. I went down the line, and I believe that worked. Well, it was good enough to save the server and capture the flag. For VPN basics, a virtual private network, or VPN for short, is a technology that allows devices on separate networks to communicate securely by creating a dedicated path between each other over the internet, known as a tunnel. Devices connected within this tunnel form their own private network. For example, only devices within the same network, such as within a business, can directly communicate. However, a VPN allows two offices to be connected. Let's take the diagram below, where there are three networks. Network Office 1, Network Office 2, Network 3. Two devices connect via VPN. And here you have the example of what we're looking at. The devices connected at Network 3 are still a part of Network 1 and 2, but also from together to create a private but also form together to create a private network, Network 3, that only devices that are connected via VPN can communicate over. Let's cover some of the other benefits offered by a VPN in the table below. Allows networks in different geographical locations to be connected. For example, a business with multiple offices will find VPN beneficial, as it means that resources like servers and infrastructures can be accessed from another office. It also offers privacy. VPN technology uses encryption to protect data. This means that it can only be understood between the devices it was being sent from and is destined for, meaning the data isn't vulnerable to sniffing. This encryption is useful in places with public Wi-Fi, where no encryption is provided by the network. You can use a VPN to protect your traffic from being viewed by other people. Offers anonymity. Journalists and activists depend upon VPN to safely report on global issues in countries where freedom of speech is controlled. Usually, your traffic can be viewed by your ISP and other intermediaries and therefore tracked. The level of anonymity a VPN provides is only as much as how other devices on the network respect privacy. For example, a VPN that logs all of your data history is essentially the same as not using a VPN in this regard. TryHackMe uses a VPN to connect you to your vulnerable machine without making them directly accessible on the internet. This means that you can securely interact with our machines. Service providers such as ISPs don't think you are attacking another machine on the internet, which could be against the terms of service. The VPN provides security to TryHackMe as vulnerable machines are not accessible using the internet. VPN technology has improved over the last years. Let's explore some existing VPN technologies below. PPP. This technology is used by PPTP, explained below, to allow for authentication and provide an encryption of data. VPN works by using private key and public certificate. Similar to SSH, a private key and certificate must match for you to connect. This technology is not capable of leaving a network by itself, non-routable. PPTP, the point-to-point tunneling protocol, is the technology that allows that data from PPP to travel and leave a network. PPTP is very easy to set up and is supported by most devices. It is, however, weakly encrypted in comparison to alternatives. IPsec, Internet Protocol Security, encrypts data using the existing Internet Protocol framework. IPsec is difficult to set up in comparison to alternatives. However, if successful, it boasts strong encryptions and is also supported on many devices. Moving on to answer the question below. What VPN technology only encrypts and provides the authentication of data? That's PPP. Moving on. What VPN technology uses IP framework? That's IPsec, and that concludes this part. Task 5. LAN networking devices. What is a router? It's a router's job to connect networks and pass data between them. It does this by using routing, hence the name router. Routing is the label given to the process of data traveling across networks. Routing involves creating a path between networks so that this data can be successfully delivered. Routers operate at layer 3 of the OSI model. They often feature an interactive interface such as a website or a console that allows an administrator to configure various rules such as port forwarding or firewalling. Routing is useful when devices are connected by many paths, such as in the example. No, I'm sorry, such as in the example diagram below, where the most optimal path is taken. Routers are dedicated devices and do not perform the same functions as switches. We can see that computer A's network is connected to the network of computer B by two routers in the middle. The question is, what path will be taken? Different protocols will decide what path should be taken, but factors include what path is shortest, what path is most reliable, which path has the fastest medium, copper or fiber. Moving on to what is a switch. A switch is a dedicated networking device responsible for providing a means of connecting to multiple devices. Switches can facilitate many devices from 3 to 63 using Ethernet cables. Switches can operate at both layer 2 and layer 3 of the OSI model. However, these exclusive in the sense that layer 2 switches cannot be operated at layer 3. Take for example a layer 2 switch in the diagram below. These switches will forward frames. Remember, these are no longer packets as the IP protocol has been stripped onto the connected device using MAC address. Router layer 2 switches. The switches are solely responsible for sending frames to the correct device. Now let's move on to layer 3 switches. These switches are more sophisticated than layer 2 as they can perform some of the responsibilities of a router. Namely, these switches will send frames to devices as layer 2 does, and a route packet to other devices using IP protocol. Let's take a look at the diagram below of the layer 3 switch in action. We can see that there are two IP addresses, 192.168.1.1 and 192.168.2.1. A technology called VLAN, Virtual Local Area Network, allows specific devices within a network to be virtually split up. This split means they can all benefit from things such as internet connection but are treated separately. This network separation provides security because it means that rules is place determine how specific devices communicate with each other. This segregation is illustrated in the diagram below. And here's the example that it was talking about. It's comparing the sales department to the accounting department. In the context of the diagram above, the sales department and accounting department will be able to access the internet but not be able to communicate with each other, although they are connected to the same switch. Moving on to answer the question below. What is the verb for the action that the router does? And that is routing. Next question. What are the two different layers of switches separated by a comma? That's layer 2 and layer 3. And that does it for this section. On to our final room. Task 6, Practical Network Simulator. Deploy the static site attached to this task and experiment with the network simulator. The simulator will break down every step a packet needs to take to get from point A to point B. Try sending a TCP packet from computer 1 to computer 3 to reveal a flag. Note, please use the Chrome or Firefox browser to complete this practical exercise. So we're going to click on View Site. So we need to send a message from computer 1 to computer 3. So we're going to move down here from computer 1 to computer 3. Now we're going to send packet. And it's sending now. It does take some time to populate the flag. So we've got the flag now. So just copy and paste that and you're set to go. So how many handshake entries are there in the network log? So all you got to do is go to the network log and count. So at 1, 2, 3, 4, 5. It's 5, and there you have it. This concludes this section.